Today, we are going to explore solids, liquids, and gases by making our very own ice cream. Hi, I'm Michelle, and I wrote yesterday's secret note. Did you know that snowy cities put salt on the roads to keep ice from forming? I know it sounds kind of strange to add salt to the roads we drive on, but it keeps us safe. Salt prevents the roads from becoming super icy because the road salt lowers the freezing point of water. Normally, water turns to ice at 0 degrees Celsius, or as we like to say in the US, 32 degrees Fahrenheit. When salt is on the road, the temperature would have to be even lower for water to freeze. This is why in the winter, many rivers and lakes freeze over, but the ocean stays liquid except at the poles. Salt keeps the roads less icy and ultimately safer for us to drive on. Today, we're going to test this theory for ourselves. I hope you're ready to eat some delicious ice cream because we are going to make our very own.
Step 1. In a small Ziploc bag, add 1 cup of milk, 2 tablespoons of sugar, and 1/2 teaspoons of vanilla extract, and any other flavorings that you want, then seal. Step 2. Add 4 cups of ice into a large gallon-sized bag with no salt yet, and then put in the small prepared bag, making sure both are sealed shut. Third, shake the bag for a couple minutes and observe. Do you see any changes yet? Then, add 1/2 cup of salt to the large bag, not the small one, and shake the bags for another 5 minutes. This may take longer or shorter depending on your bag. Fifth step, once the milk has solidified, it's ready to eat. Serve as is or turn it into a nice ice cream float. Eat it as fast as you can because it's going to melt.
I hope you enjoyed your delicious ice cream. Now, let's discuss. How did adding salt help us make ice cream? Well, first, we need to talk about ice melting. Ice takes an energy or heat from its surroundings to melt. This is why your hand gets cold if you hold ice. Your hand is warmer than the ice, so it gives the ice some of its heat. When it loses heat, your hand gets cold. Think of it like a trade. When something is hot, it donates heat to anything that's cold nearby. Back to our experiment. The milk is warmer than the ice, so the milk gives heat to the ice until they're the same temperature. Now, the milk is getting colder. The milk is able to give a lot of the heat to the ice because the salt helped the ice to be very cold. That means more energy in the form of heat goes from the milk to the ice, so the milk gets colder. That was a lot of talk about temperature. Let's take a moment to talk about the states of matter. When we talk about states, we don't mean the ones on a map. Instead, a state in science is what form a substance is in. The 3 states are solid, liquid, and gas. The easiest way to understand this is with a common example. Say we have a glass of water. In the glass is a liquid. The particles in the liquid, which are like atoms but a little bigger, have space to slide past one another, like people in a big mall, or you and all your atom friends walking through the halls at school. The particles are moving in all directions, each going on their own little trip. This is why liquids can take the shape of the container they are in. If you poured the cup of water on the ground, the water would spread out. Now, let's think about what would happen if we put the cup of water in the freezer. After a while, the cup would contain a block of ice. It's the same substance, the same atoms, but now they are closely packed together. No atoms are bouncing around and spreading out. If you poured the water on the ground now, it would come out as a block of ice. The water is now in the solid phase of matter. Now, what would happen if we put the water on the stove? It would eventually get very hot and boil. When it boils, liquid water turns into a gas. It evaporates and moves into the air. You might be picking up on a pattern about the states of matter. You can heat a solid to turn it into a liquid, and heat a liquid to turn it into a gas. If you have a gas, you can cool it down to make it a liquid, then cool it more to make it a solid. This is true for substances other than water too. If you heated metal for a long time, it would turn into a liquid. If you kept going, eventually it would turn into a gas. To see some really cool science, try looking up liquid nitrogen. The states of matter are pretty easy to identify, but they also follow some basic rules. Solids are rigid, which means they don't slosh around, and they keep their original shape. Liquids fit into whatever container they are in. They learn to adjust. and gases are always bouncing around. They will fit all of the space you give them. You can also determine the state of matter of something by looking at how close together the atoms are to each other. Remember atoms from before? Atoms make up everything in the world. As you can see, the particles in the solid are super close together and have no room to move. The particles in the liquid have space to slide past one another, and the particles in the gas have a ton of room to move and collide with each other. Today, we used ice and salt to freeze liquid milk, which turned it from a liquid to a solid. Before, the milk particles were more spread apart, but now they are super tight. Now, for today's featured scientist, we have Mario J. Molina. Molina is a Mexican chemist who won a Nobel Prize in Chemistry in 1995. He studied the effect that man-made compounds had on the ozone layer, which is the outer layer of the Earth's atmosphere. Today, Molina is a professor at the University of California, San Diego. Awesome job, chemists! I hope you enjoyed making your very own ice cream. Stay tuned for our next experiment where you get to make your very own cell model out of Jell-O.